Hi everyone, welcome back. Let's continue with the subject compiler designs. The next topic in compiler design was bootstrapping. So what is this bootstrapping and where we use this concept? A bootstrapping is widely used in compilation development. So whenever we are compiling from source code, that is the high level language to assembly level language, this bootstrapping is widely used in the development phase, the compilation development phase. It is used to produce a self-hosting compiler. The main important thing of this bootstrapping is it is going to produce a self-hosting compiler. That means it is a type of compiler that can compile its own source code. It is a type of a compiler, that is bootstrapping is one of the type of a compiler that can compile its own source code. A compiler can be characterized by three languages. One is the source language and another is the target language, and here the implementation language. Source language S, target language T, implementation language I. So what are these three languages? So far we had seen the high level language, assembly level language and machine level language. Then what about these three languages? So these three languages are useful for compilation development. Okay, a compiler can be characterized by three languages: the source language, which is in high level language, and target language, which is an assembly language, whereas implementation language is used to convert the source to the target. So it acts as an intermediate between the source and the target. Implementation, we are going to be convert source to target. So bootstrapping is a process by which simple language is used to translate more complicated programs, which in turn may handle an even more complicated programs, so on. So the main use of this bootstrapping is whatever the complicated programs that are there, that whenever we are used to convert the simple language to it's a more complicated programs, then this bootstrapping which in turn may handle an even more complicated programs. Okay, so sometimes there is no need of using this bootstrapping process when the compilation is going on, whenever it is a simple languages, simple programs. So this bootstrapping will play into role whenever there are more complicated programs. So the clear what exactly the bootstrapping is going to handle more complicated programs when the compilation process is going on. Okay, so let's see. I said a compilation process is characterized into three languages. One is a source language, target language and intermediate language. So the source language, whatever the source code that you are giving, okay, the source code. So the compiler is going to implement it some language, that is the intermediate language. So with the help of the intermediate language, it produces a target language, that is the assembly language. A target language is in the form of assembly language. Now let's see what exactly the inner process is working on. What if you use a bootstrapping process, the compiler, how the source is converting into the target language with the help of implementation language. Let's see. In bootstrapping, this compiler diagram is represented as a T diagram. So this is a representation of T. So source, target and I, with the help of implementation, the source is converting into target. So this can also be represented as STI. The source is converting into the target language with the help of implementation language. Let's say a simple example so that you'll understand how the process is working on. Okay, so here in our example, the source, target, okay, the source, target, with the help of implementation language, what we have to be convert? Source, target. Okay, so here this is the process. The source has to be converted into the target language. Okay, so whatever the code that you are taking, that is with the help of implementation language, you are finally converting the source and target, and with the help of some other language, whatever it may be. Okay, so here in between, how you will get this? So this is a source and this is a the another language. Okay, the source is converting into some other language by taking an intermediate help. Okay, and finally you will get the source with target by taking another language help. Let me take another example so that you will understand what exactly the process is going on here. Okay, how it gets this, how you got these. This is an input and this is an output. By taking one intermediate help, you are producing the output of another language. Okay, again this will be converted into another source and the target by taking another language help. So everything is taking an intermediate language help. Okay, so actually this can be represented as source, target, intermediate. Okay, and here you will get another T. This is the intermediate language, another M language. Let's take the machine language, or else source, target and machine language. Okay, so here these two must be same, and here these two languages must be same. This is on same language. Okay, so these two must be same and these two must be same, and finally you ignore these languages and the output you will get is source, target. Okay, with the help of another intermediate language. Let's take a simple example how these process is working, how the compilation process is done by using the bootstrapping. Let's take the Pascal translator. Okay, let the Pascal translator, that is the C language, let's take. Okay, that Pascal translator is converted into written in C language. This is a probe. Okay, and where are the Pascal, PC is the input, let's take, and C is an output. Let's take these two are the languages, PC. Okay, PC is the input and C is an output. Now let's create a Pascal translator in C++. Create a Pascal translator in C++. So here the question is the Pascal translator written in C language, but I want the output, the Pascal translator should be create C++ language. I don't want the C language. I want the C++ language. How the process is going on? Let's see. Okay. So first the input is the PC. Okay. The PC and the output is C by taking an intermediate help, Pascal written in C language. So this is a Pascal written in C language. Okay. Now convert it. Convert by taking, and you'll get the, you want the output like PC. The Pascal translator should create a Pascal translator in C++. Okay, so the thing was the Pascal translator you had to be written in C language, but here I had taken one intermediate language as a C. Now I want to create a Pascal translator in C++, not in C. I want the output in C++. Okay, the Pascal translator is converted into C language. Okay, with the help of the translator C++, not C. So how you will get this? So with the help of the bootstrapping, we convert. With the help of bootstrapping, we convert PC C by taking the intermediate language C. So C is an input and you want the output as a C++. So this is an intermediate language. C++, take any variable I with the help of some intermediate language C. So this is one task. Okay, and internally this will be converted into so here you will get the C as an output. So with the help of the C you need to convert into C++ by taking another intermediate language. Okay, and the final output you want is, okay, So PC, so by taking the intermediate help C++, you'll get the C language. So what I said, according to the bootstrapping, these two languages should be same while you're converting. Okay, so the final output is Pascal translator is converted in C by taking C help plus the C intermediate language, and finally you will get P C. Okay, so just finally you will get PC, C, C++. So this is an input and this is an output. So don't be confused. So whatever the language you are taken, if you want the output as some other language, okay, by taking intermediate language help, you can convert. Okay, that is the compilation process by using the bootstrapping. Here input whatever you are given and output whatever you want. So the intermediate languages you can take any help. So the C is converted into C++ by taking another intermediate language. Okay, and finally the Pascal translator is created in C++ and the final output you will get is in C language. The Pascal translator is created by using C++ and you'll get output as C. This is about the bootstrapping. Thank you.